Okay, hey everyone, let's see if this actually works. It seems to work, at least well, OBS which I'm using for broadcasting seems to tell me that I'm actually broadcasting, so you should be able to hear me and I can hear myself on YouTube, which means I'm live. Hello everyone, thanks for coming. Today, as usual, a couple of news and then we jump into a reverse engineering challenge. So one of the things you asked about in the comments under my previous video was, could I do some reverse engineering challenge which wouldn't be super easy? Obviously I cannot. So it's like this. You know, my live streams are 1 hour, right? So it means that I can start doing one, but I'm pretty sure I won't finish it. So that being said, the commenter basically specifically said that they want to know how to start with approaching a Crackme, which isn't super easy, and how to go around it. So yeah, I can show how to start, and then maybe I can do a write-up on my blog on how to finish it as well, because why not? So we can do it this way. Okay, so let's start with the news. First of all, as you can see, the art I have all around, like here for example, starts to change, and it will change even more in the future. I also decided to stretch my camera out a bit. And yeah, so this is work in progress. I did actually ask some professional graphic artists to make a proper layout for me, because this at the bottom is actually like part of the layout of my blog. The usual background I had and the one I have still at the end of the stream was actually the cover of my book. So, you know, it was like just bits and pieces put together and they don't look good. So yeah, so I hired basically 2 artists to do it a little better, and the animation used at the beginning is one of the steps in the right direction, I think. The gradient font here is just my tweak. It will change, don't worry about it. Cool, so first of all, today's moderator will be KrzaQ. That's actually how you spell his name. So if you have any questions, his name is here, down here. Just ask him on IRC or on YouTube, and he will basically tell me, because we have a, voice communication. So that's pretty convenient. That means I don't have to look at the chat, and still your questions do get to me. This is his website if you would like to see it. Yeah, and it's actually, if you're into C++, you totally should see it. It's he's like really good in that language, way better than I am. Then, shoutouts to Live Overflow. As always, he actually did like this great video recently about my channel, so totally like I got warm, fuzzy feelings near my heart. Thank you. Also, totally go check out his channels, especially if you're into security and CTFs. His channel is really awesome. If you subscribe, then, which I recommend, you will get notifications about new videos, and really his channel is really awesome, so I fully recommend it. Apart from that, last time we chatted about, well, I talked about, because I guess this is about me talking, stack cookies and stack canaries. Yes, they are the same thing, and actually if you go to Frack, I don't know if you know Frack. Frack is this really old school and really awesome security magazine. Like it's not published by printing, it's just on the web. It isn't published often either, but there are some really good articles on basically on stack exploitation, also how to get around cookies and so on. One of which is made by Pi. Pi is actually working for Microsoft nowadays in one of the security teams. I also worked with him in one of my previous companies. And he has this really good article with a lot of references. Actually, if you go to the bottom of the article just before the exploits, there's a good reference table. Be sure to check it out if you're into exploiting stack cookies and so on. And again, check out the Frag magazine. It's like really awesome. They're like really good things there. Some really old, because like the first issue was dated 85, so I was barely alive, and I guess some of my viewers were not even alive at that time, but it's also good to know some history. Cool. So, Crackme. Today's Crackme will be from Crackme's DE. Crackme's DE was usually the website where you get a huge collection of Crackmes on different levels, and you can basically hone your reverse engineering skills. Now it's down again. It's sometimes it's up, sometimes it's down. If you want to look for an archive, it's actually on yeah, just type archive and you'll get a link. It's on Tools for You. If you're into reverse engineering, this is the site you probably should know. It has a huge collection of papers and tutorials and tools on reverse engineering, so you basically need to know it. So I did download a Crackme from there. Basically, so okay, I need to probably mention this just to be sure. If you have any ideas for the next stream I should do, just go on YouTube on my channel, which is, as you probably know, this one. Well, you are here, so you probably do know about it. And if you go under a video, for example, this is the previous video, there are comments, right? And in the comments for this video, put ideas for what I could talk about in the next video. And one of the things here was, it was actually top voted when I looked at it. Anyway, it's somewhere here. It's basically how to start with a medium hard reverse engineering challenge. Yeah, this is the one by Lemon. I think there are some comments now which are higher ranked, but when I looked, this was the highest ranked basically. And totally do put your ideas what I can talk about under the comments in under this video. And I'm going to basically pick a topic from there. Okay, so yeah, so I went to Crackme's DE, or actually the archive, and I went into the directory called Level 5, Professional Problem to Solve, which, so there seem to be 9 levels in the archive. Let me quickly show that to you. Yeah, and I choose the middle one. Like level 5, let's see what's that. And then I picked basically a random one, which is for Linux, since I feel like doing Linux reverse engineering today. Maybe I should have chosen one for Windows instead. We'll see how it goes. Oh, one thing I want to brag about, I finally did something I wanted to do a long time ago, which is, first of all, update all my compilers. You probably remember from my old streams that on Windows I had basically like really old GCC, and that wasn't too good. Now I did an update of basically everything, and if I type switch, I get to choose which compiler I want to compile in. It's a just an idea I'm throwing out there. The script is too terrible to actually share, but it's quite easy to make one. And if I type switch and whatever, like py35232, then run Python, it actually does switch to the version I did choose, right? And same with all the other compilers, clang and so on. So just to throw an idea that maybe you'll find a script like that useful as well. Cool, so let's start with the Crackme. There's actually a README file attached. Oh, the Crackme is called, I don't know even how to read it. Ox full me, or is that 0x full me? Yeah, basically it's like that. And there's a README file. It's always good to read the README files. I see there are already some questions, so I might address them in a little as well. Anyway, so just to get it through here, basically the person who made the offer of this Crackme said that there are some anti-debugging, anti-disassembling stuff, not so scary, and some mixed techniques which he did, or they did, see in malware, which is cool. I can use whatever tools I want, and I can abuse the binary any way I want, and I need to find the correct password. Obviously it's not written here, but it's obvious that the correct password needs to work on the unmodified version of the binary, because, if you could just modify the binary, I would just replace the whole text section as in the code section with my code, which accepts any password, right? And problem solved. But that's not what the task is about. The task is actually about solving this one and having a correct password to the unmodified version. Yeah, and I believe this is the offer. So shout-outs to him. Cool. So let's I guess start this, and this is going to be quite funny because I already know what happens. I didn't look at it, but I did run it, and so I ran it, and it tells like enter password, right? Well, okay, I'm going to enter the password, and it stopped. And I actually, as you can see, part of what I've already written here, right? This thing, it's I believe this part. it didn't accept. So this is already a hint, I would guess, that it reads up until like this many letters. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is it 11? Yeah, so something like that, 10 or 11 letters. So maybe that's like 10 and the new line, like enter, right? Or maybe that's just 11 letters. And the rest it just ignored. And it also stopped, which is quite funny. So let me, which means if I type jobs, it's actually, you know, in my background stopped. So I'm going to do a foreground on it, which means run it again. And let's see what I can do now. Well, I can type stuff, but when nothing happens, I can press Ctrl-C, but nothing happens, and I can press Ctrl-Z and nothing happens. So how do I actually kill this process? Well, that's easy. I'm going to start a new console. Since I'm running out of shortcuts which could actually kill it. I could obviously close the console, but I prefer to do it like this. Kill all -9 and the name OX F001ME. Yeah, and it's killed. So that's quite funny. So okay, questions. Will there be any normal videos on my channel? Yes, there will be. I'm basically I have some scripts already written for some videos, and what I'm waiting for is basically the graphical artists I hired to finish well, the art. And once the art is ready, I'll start publishing videos. Not too many of the videos, because it does take a lot of time to make. Basically, you know, 1 minute is one minute of a video is like 1 hour of work, if not more. So it takes time. Any collaboration with Live Overflow? We discussed it. Maybe something will happen when I start making videos, because, well, currently, you know, I'm making a live stream and he's doing videos, so that's actually something different. We have different approaches. But yeah, totally. I mean, I totally love his work, so why not? That's, yeah. Okay. So why does one minute of video take 1 hour of work? Is basically because there is, you know, you need to write down the script, then you need to record everything, record the screen, make some animations, editing, edit the vocals which you record as well, blah blah blah, and like in the end, when you have, for example, a 10-minute video, it turns out you worked on it for 10 or 15 hours. It just takes so much time, yeah. How do I make money? I actually work for Google, so yeah, I do have a day job. Yeah, that's the core of it. Sweet, so let's get back to this. Again, if you have any questions, ping this guy on IRC or on YouTube. So what do we do now? strace to the rescue. If you don't know, strace is actually a great tool which acts as a debugger and uses the debugger API, and it hooks to the, well, attaches to a given target, for example, our Crackme, and it stops the target. It actually gets notified when the target tries to run a syscall, as in a kernel API, right? Command or function, and then when that function exits, it gets notified again, and it grabs the parameters at the start of the syscall and the return value at the end. And okay, and we already see something here that it actually exited its segmentation fault, which isn't good, and it did on this. It didn't work due to this. So ptrace trace me is one of the most basic anti-debugging tricks on Linux which you can encounter. It basically means that the process, if the process runs it, it will return, if I believe, if I'm correct, 0, if I remember correctly, in case there is no debugger attached. And if there is any debugger attached, which means the process is already traced, then it will return -1, like, no, you're already traced, you cannot do it. So the application, the Crackme just detects it. And yeah, and due to that, it knows that I have used this debugger. strace again is using the debugger API, which is the ptrace API, so I cannot use strace. This is what what it means. Now, I'm actually going to look in a hex editor on this I'm going to run, my favorite hex editor is actually this one, which is Hex Workshop. You might like different hex editors. I mean, there's a whole bunch of them, right? I like this one because, for example, if I do file format reverse engineering, I can choose a structure library, like a structure from library, for example, zip library, and then I have all the structures inside the zip file. The collection isn't huge, but it's really easy to write them. So yeah, it's a paid editor though. I'm pretty sure they're like open source, good open source text editors as well. So let's look how it looks like. It's actually quite funny. You can already see here that it looks quite funny. The file isn't huge either. It's what? It's like 7 kilobytes, I believe. Let's just do it. Yeah, no, it's 3 kilobytes, so it's even smaller. And if you look at the ASCII side, there's quite a lot of X's. Why are there so many X's? That's quite funny. So I'm pretty sure it's obfuscated in some weird way, but I have absolutely no idea what way is that at this point, but we'll get to it. I don't know, PQ, it's quite funny. So yeah, it doesn't look compressed. So what I usually also do, let me span a Windows console for a change again. It's I have a tool called ENT, which stands for entropy. And what it does, it generates a PNG file. Generated a PNG file. If I do ls, ls is actually an alias for dir in my case. Yeah, there is a PNG generated, and the PNG looks like this. To zoom in, it's just a simple chart. Basically each column, each bar stands for 256 bytes of a file, and it tells you the entropy, where the entropy is how much the bytes differ actually inside that 256 byte block. If they differ a lot, there are various bytes. Then the bar is high. There is actually, like, it goes, I think, around here, and here would be red. If it's low, then it's violet or greenish. What this means is that if you'd actually do this, like run this end on something which is compressed or encrypted, because compression and encryption in the end lead to high entropy, then you would basically know that, hey, I'm dealing with compression, or hey, I'm dealing with encryption, and you would basically set your expectations correctly. Now here, the entropy level is like greenish or like orangish, or is that yellow? Well, whatever. Which means there's probably no encryption, no compression. We saw that in the hex editor, there was not too much entropy. If you're interested in this tool, by the way, you can find it on my blog. I'm not saying it's a good tool, but it's something I'm used to. I've written it, I think, like 10 years ago. Just type ginveil and there should be in the tools section. Yeah, in the tools section, there's like, is that the Polish tools section? I'm pretty sure I have an English tools section as well. Yeah, it's here, and then there should be a post about, there's also a post link there, like, what's entropy, and basically how do you read this bar. This is like for some more complicated executable, and here you can actually see that it has a compressed text section. So yeah, this is a tool I use for the recon phase, the recon being a reconnaissance, where I basically get to know what the binary is about, right? So I can use the information later on. Okay. Where can I get the background like that? So my background is really cool, right? Actually, like I think my wife told me about it. It's called Wallpaper Engine, and you can find it on Steam. And it has quite a lot of different animations and so on. I'm probably going to write my own at some point, but I didn't get to it yet. That's one of the default ones. I think it costs like 4 francs or like 4 euro, whatever. Cool, so let's get back to hacking. What do we do now? We know we cannot use strace, and we know it's not encrypted probably, and it behaves weird. Let's just open it with IDA or Binary Ninja. Maybe I'm going to open it first with Binary Ninja. Here's Binary Ninja. And let's see what I can see here. So that's actually not a lot of code for the basic block, for the beginning block, right? It just calls some function. And if we go here, then it pops EDX. The EDX is the return address, right? And then it adds to the EDX OXB, which is 11, if I remember correctly, and I should remember correctly. And then it puts back to the stack and returns there. So it actually doesn't return here, right? Let me press space to switch to this view. And I could use, by the way, IDA. I'm using Binary Ninja. I actually like this tool as well. because I know that it's more affordable than IDA, especially with all the compilers and stuff. That's not how you pronounce engine, it's engine, right? Sorry, engine, my English isn't too good. Cool, so yeah, instead of returning here, it returns to address 85 plus 11, which would be somewhere here probably. So it's OX85 plus OXB. That would be, Python is really useful for calculations, it's 90. So it jumps to the address 90. Now, 90 is, what was the address here? It's actually 8F, so 90 is this one. How do I switch this to code? Change type. No. Okay, you know what? I'm going to actually run IDA. I still need to... So one of the things that will happen in the future on this live stream will be my colleague Karstein will be joining me, and he will be telling me all about Binary Ninja and how to write plugins to it, and that will be the time when I'll actually hopefully learn how to use properly Binary Ninja, because I honestly, as you can see, cannot use it. Okay, again, this... So this calls here, and then it returns, and it should return here, but instead it returns here. So IDA, well, didn't detect it, but just did something with the code. What is happening next? It pushes some location, and then it returns. This is basically a jump, right? So, you know, return gets the address from the stack, right? And therefore, whatever is on the stack, what was pushed last, is the return address. So this is the return address, so it jumps here. And then what happens here? It puts this offset to EDI, jumps somewhere else, actually jumps here, and puts the same value somewhere else, and it calls this function, and this function actually... Okay, so basically what I can already see here is this pattern, right? This pattern is being used the second time, which means maybe I'm going to write a short Python script which gets rid of all this nonsense and puts, like, I don't know, some knobs there, or like a straight out jump. So IDA can understand it better, right? Because, yeah, again, it's the same pattern, like pop from the stack the return address, then add 11 to it, and then push it back on the stack and jump there. And, yeah, which means it actually jumps over this, and it jumps here. Now, is there anything interesting happening here? It adds to EDX 14, and then pushes it on the stack, pushes something else, some null sub, and it returns there. And what it does, it just takes another value from the stack and it returns to it, which means that would be EDX. EDX here was pointing at, after adding, right? It was pointing here. So plus E would be, I'm going to undefine this block. Yeah, and okay, CLD. CLD means clear direction flag, which the direction flag is actually used only, I think only, I'm going to say only, but that might not be the case. It's only used by the streaming instructions, as in repeat, as in rep, for example, move SB or something. So this is probably used to copy shift data around or do something else with the data. For example, fetch a byte, XOR it, and put it somewhere else. So let's see what happens here. Again, the same obfuscation pattern is used here. So I know I should jump to this block. And here it null sub. I'm going to know to change this to, like, I don't know. Again, red. I can press P in Binary Ninja, not C. I tried to press C, but in Binary Ninja I should press P. Thank you, Life Overflow. I may try it in a sec, actually. Can I make a short video about reverse engineering for the beginners and easy level, that wouldn't be a short video. I'm actually thinking about making, you know, a series, probably a commercial series, which means I can spend on it quite a lot of time and do it properly for to do it about like beginning of reverse engineering and assembly. So if you like the idea, just let me know. And again, this is pointing to here, and I'm going to add E here, which means I go, I don't know, where do I go? My hex math isn't the greatest. Plus 1OD. So, by the way, what I'm doing now is I'm basically just looking around the code to get a feel of the code. It's quite important to do that because you can notice some patterns. I mean, I found quite a lot of patterns already. And I'm pretty sure, yeah, this is like CLD, and then these are like the only two instructions which are important here. The CLD here, and then the move, I'm sorry about that. Where is my instruction? Yeah, and then move ECX here. Because when you do the streaming instructions of, you know, repeat something, repeat and do something, on the strings, so I think they're like streaming instructions, like string instructions. We'll get to that. Anyway, you put in the SCX variable how many bytes do you want to process, and this is probably it. So I need to remember this one. And also before that, before this instruction, there was this. Like, this is another important instruction. And like, so basically, after I analyzed already this match code, I only found 3 instructions which are actually meaningful, but everything else is obfuscation. So yeah, let's see what happens. This obfuscation pattern again, blah blah blah. Where do I usually end up? Do I end up here? No, I actually skip this E8 byte and go to the next one. And then loads SB. This is the first instruction, which basically grabs 1 byte into the AL register. Why are we doing this? This doesn't make any sense. Is load SB. If it would be store SB, that would make sense. But yeah, I think this instruction is just like garbage. It doesn't do anything. But yeah, it grabs basically 1 byte and puts it 1 byte from the ESI register, from where the ESI register points to in memory, and puts it in AL register. Yeah, and then again, this is the same pattern probably. Blah blah blah. It jumps here. Then it jumps here. Yeah, and then it XORs it with 5. This is so you saw a lot of X's there, right? Do you remember? This is actually X. 5/8 hexadecimal is actually X. So when we looked at the file, right, in a hex editor or whatnot, then there are quite a lot of X's. So we already know that these are not X's. These are just like zeros, as in 0 bytes, because after XORing X with X, we'll get just 0. Can I do a video about how to set up my Linux/Windows environment in English, because I did one in Polish? I can do that, why not? I need to think how to do it properly, because last time it took me 3 hours to actually record the 3 hours of live streaming session. I'm not sure you want to watch that. I probably should like just write it down properly and do a video about it. Also, one thing to note is that in newest versions of Ubuntu server, for some reason, Genome Terminal does not work. And as you can see today, I'm using actually Xterm because console from KDE was annoying me. I couldn't copy paste from there. So yeah, so today is Xterm. But I need to still figure out why Genome Terminal is not working in this configuration. Okay, so then it's XORed, and then we'll probably see a store this, the byte which was processed somewhere, which will be stos SB, like store byte. And this, yeah, this is exactly it. And then there will be probably a loop somewhere here. Yes, I want to. Yeah, and here's a loop. It jumps to the beginning. Now, this loop runs exactly this many times, and by this many times I mean, where is the, yeah, exactly this many times, this many iterations. So I know that from the address which was put at the beginning in ESI, right, which is this address, I need to XOR that many bytes, and then the loop So I'm sorry. Let me just go back here and yeah, this is where the loop ends, and these are the first bytes. Everything here doesn't make sense. Like everything which IDA actually shows here doesn't make sense. These are all the encrypted instructions. So what I need to do is I need to actually write a Python script which does the XORing. I could do it in IDA, but IDA API, I'm not really a fan of it. And if I do it only in IDA, then I will have a problem that I will not be able to debug it. And I need to be able to debug it, therefore I need to do it on the real executable. And this is where, you know, where Python programming comes in. So if you're new to security, you probably need to learn Python. So is it not genome, it's just gnome? Huh, spelling is hard. Okay, let me create a script. I'm going to call my script go-py because that's usually how I call my scripts. Here it is. Now, I don't need to import anything. I just need to read the file into memory. This is how you do it in Python. I'm using Python 2. Python 2 because Python 3 is actually annoying in the way that they changed how strings work a little, and you have to, and also they put the normal method of decode and encode somewhere else. That's quite annoying in all honesty, so I'm not going to use it. Then read binary. I'm not sure if I'm going to run it on Windows or Linux, so the binary flag here must be set. And yeah, just read it. And now I have it in memory, like in the D environment. But I'm actually going to change this. What you would get a string, but what I want is actually a byte array, because it's quite easy to operate in. Yeah. Okay, now in D I have D as data. I have the content of this file. Now, what I need to know is, I need to know just a couple of things. First of all, I'm sorry, this is not what I meant. I need to know the address in file, the offset in file of this address. Because, you know, this is the address in memory, right? And so-called, it's like so-called virtual address from like virtual memory. Now, what I need to know is I actually need to know the position of this in the file, and IDA has it here, so this is the offset in file. Like from the beginning of the file at this offset, there is, well, these bytes. So I'm going to write it here. Offset is equal to this, and then like length. The length is again what was put in ECX. Blah blah blah. Oh, it's here. Yeah. So it's yeah. I'm sorry. This is the correct one. And now I need to XOR it with the key they have there, and I'll need to patch one more thing, but I'll get to that later. How to XOR it? I just map it. I wonder what will be the outcome of a map like that. I don't know. I'll change. I'll check it in a sec. Anyway, so lambda x, and I need to XOR x with 58, which is again the x character, capital X, right? Yeah. And this should XOR it. I have absolutely no idea what type this will give me. Let's just see. Python go py. A list. List of what? So list of ints. Perfect. Can I just cast it to a byte array? No, you know what? I'm going to do something else. I'm going to do like chr. And then I'm going to do this. What I'm writing probably isn't optimal, and it totally doesn't matter that it's not optimal. That's okay. It doesn't have to be optimal. That's not like production level server for 1 million users. That has to be optimal. This doesn't. So please forgive my probably quite lousy coding here. Now, what I need to do is, because if I patch this, right, I patch all the encrypted data, I decrypt it inside the binary. Now, there's one important thing here. I'm saying that there's XOR encryption here, but I showed you just this chart, right? And I said, oh, there is no encryption. Now, what I meant by saying there is no encryption is actually there is no encryption apart from really naive encryption likes, because so encrypting by XOR doesn't change the entropy level, and the same is with substitution and crypters, ciphers, basically. That doesn't, you won't see that on on the entropy level, there will be no peak. If you'd encrypt, for example, with AES, then yeah, totally, you will see like a huge spike in entropy. But for a simple XOR with 1 byte key, no, you won't see it on entropy at all. That's just due to how the entropy is calculated in my case. Now, what I need to do, because again, I decrypted, but when I start the binary, my output binary, it will be decrypted again by this code, right? And I want to avoid it. The easiest way to avoid it would be to this instruction. I'm going to patch this X. I'm going to change it to 0, because if you XOR anything with 0, it just gives you that anything you started with, so that won't change anything. Therefore, I need the address of this instruction. It's actually on this offset, which is 154. So D154 plus... now, here's something that's really handy as well. Did anyone see my browser? Okay. I actually have it mirrored, but... yeah, this is the address, like Genvale Vexillium org dump /opcodes.txt. That's just a mirror with us. It's like a list of opcodes and instructions for x86, just the basic ones, done by this person, which is really awesome. And I'm going to look for how XOR is encoded. Where is XOR? Here, it's here. So I know that my argument is just a register, like there's AL there, right? So that's 8-bit register. And then there is, that's not it, because there is like memory something, and I have a constant, which means this is this variant. And it's encoded like this. There is the 34 is the opcode of it, and after it, there is an immediate value 1 byte, which is X in this case, like 58, right? Therefore, I can verify it by switching to the hex view here, and yeah, it's 3458, which means that the key 58 is actually 1 byte further from the offset which I put in my script, so I need to do +1. And now I can change it to 0. And I have this changed to 0, therefore I can now I can save it to a file which is open deobfuscated. That's not really true, it's not yet deobfuscated, but it's getting there. It might get there at some point. And I'm going to write, basically I need to convert it to a string. Can I just do string on this? Let's see what happens. Yeah, now I'm going to run the script again, go Python, and it did output this deobfuscated file, which is the same size as this one, the original Crackme, but let's see if it actually differs, right? So I'm using on my other monitor, sorry, on my other display, I have Total Commander, and yeah, I select both files, then I click compare. You can actually use whatever comparing tool you would like, and I'm going to see where did it XOR, and I already see that I XORed everything, and I shouldn't have XORed everything. I should have XORed just yeah, this stuff. So again, we change it. Okay, so Binary Ninja can support XORing without even leaving Binary Ninja. That's pretty awesome. I'm going to check it out in a sec. I just need to fix this script first. So offset plus length. And this, I'm going to call it K for some reason, and yeah, no, that's not it, that's it, yeah. And then D is equal to D up until offset. I take the unchanged, then, yeah, I can do that. I take the first part of the file, which is not XORed, and then I added K to it, which is the XORed part, and then I still need to grab the rest of the file, which is offset plus length, up until the end of array, and now it should be fine. Let's see if it is. So I'm going, Total Commander should actually tell me Oh, I did close it again. If I wouldn't close it, it would tell me that the file has changed and it needs to change it. Okay, so here are the changes. First change is here, right? The key X originally, now it's changed to this, like a dot here, which actually is 0. And then we can see the XORed data. I wonder what this is. This looks like... It looks like we have some obfuscated strings already, so I'm going to look in this, which is the viewer from Total Commander. And yeah, there are already some strings. I can see some strings, which is pretty awesome. So let's see in IDA what happens. I'm going to launch new IDA. Yeah, let's continue, whatever. Yeah, whatever. And then I'm going to jump straight into the address where I have the obfuscated data, which is here, right? Like, oh, it returns somewhere, but it's probably here. Yeah. So I'm going to press G, type the address, and hello, hello. This is the unobfuscated code, so I can actually shut this down. I'm probably going to need to open it again later. And let's see what happens here. So I jump somewhere, and this is the same obfuscation pattern. I should remove it, but I'm too lazy to do it. And then I'm just going to, since most of the code is already unobfuscated, I'm just going to scroll through the code. Here I don't know what's happening, but I know this pattern, so I'm going to undefine it. Yeah, it jumps somewhere, and this looks like just a string. I have absolutely no idea what this is, though. We might get to it later on at some point. Maybe it's code? I don't know. Let's undefine it. And let's do this. No, it absolutely doesn't look like code. It's just probably some string which is also encrypted, obfuscated. I'm sorry. So I absolutely know that I should be doing. Yeah. And then whatever, then I'm going to check this. This looks terribly like the our normal, usual obfuscation, so I'm just going to ignore it and change it to code. What's this? Yeah, nothing too interesting. I'm going to scroll back. And I'm going to undefine this. I should actually undefine everything here. And yeah. Here. Here as well. Yeah, just like boring stuff, but and changing quite a lot of stuff into code. Okay, it actually grabs the offset of this string, which I was wondering what is it. Oh, there's a question. Do I prefer to statically reverse engineer a Crackme? My first instinct, which is probably wrong, is to find the ptrace call somehow, nop it, and try to debug it. It's a good question. So it's like this. At the beginning of my reverse engineering adventure, I prefer to work with a debugger. Currently, I prefer to work statically up until the point where I actually need to use a debugger for something. I don't know why is that. One of the ideas I have why is that because currently I can keep basically a pretty good mental map of what is happening in the process up until the point which I'm reverse engineering, which means I don't have to verify it in a debugger so often. That doesn't mean that there's anything wrong with using a debugger, and probably I would be faster if I would be using a debugger. I'm just in a way lazy not to use the debugger and just focusing on static analysis. But totally, I could do as you say. I could find the ptrace with the debugger. Actually, I could set in GDB a catch point which would catch the ptrace me call. I could patch it. This is interesting. This is a call to the Linux API. Yeah. Usual obfuscation. This is quite funny. I wonder what they are up to here. Is it just an obfuscation or is it something else? Because usually when I see like pop flags push flags, that means that somebody is checking there's a flag called step flag or trap flag, I think that's believe like TF. And that's the flag which, if it's present, then the CPU will issue an interrupt after the next instruction, which means it gives the debugger a chance to single step through the process just by setting this flag for the process, right? And usually what some Crackmes do is they grab the content of the eFlags register and checks if that flag is set, because if that flag is set, that means that the debugger is present, because the debugger needs to be handling it, or something which uses the debug API, and therefore they can like say, hey, if there's a debugger detected, I'm absolutely not going to execute in a normal way. Okay, let's continue marking everything as code. I wonder if this always has the same constants, if I can just like do a simple replace here. Why does it seems to be so I wonder if we'll see a pattern where this address pops up and then it pops up again in this distance between the address, right? The addresses. Probably that will be the case, and if that's the case, that means it checks character by character if the password is correct using some fancy magic, which I am not able to trace yet. So let's see what happens. No, it didn't pop up yet, and it should have already. So that's one hypothesis that didn't work out. But yeah, it's good to make, you know, some assumptions while you're doing it, but maybe I will expect this one. If it doesn't work, just throw it out. If it works, then you might be prepared already for what's coming. Obviously, to get any ideas, you do need to solve your share of Crackmes and gain some experience. Otherwise, you just don't have information, right? So, by all means, if you want to be a reverse engineer, do quite a lot of Crackmes or other challenges. This was quite interesting. There's like a negation here. I wonder what are they up to. There's some address which I didn't touch yet. No, this is... Oh, this is probably the address of one of later characters, one of these characters. I'm going to actually do this. How many X's are there here anyway? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, so that's exactly, you remember 11, the constant from the beginning of the stream, where I said that, hey, this is probably 11 characters. So my bet is that this is an encrypted password, and this is the place... Are these 11 characters again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, and there's something weird later on. So my guess this is the place where if I enter a password, it's going to be put here. And yeah, this is the place where the encrypted password is actually stored. That's quite enough guesses to actually start doing some fun tricks on this, like doing... So one thing which you can do sometimes on the Crackme is you don't have to reverse engineer it, but you can do so-called side channel attacks. A side channel attack is basically if the Crackme checks the password one by one character by one character, and after the first incorrect character, it already says, no, this is wrong. Then what you can do is you can basically brute force it, because you know that the execution will progress at the moment where you hit the correct character, and therefore you can write a script for the debugger which tries each and every character on each and every position, starting from the 0, and when it hits something which progresses the code further to areas which were not seen before, then you know you hit the correct character and you go for the next one. That's totally the simplest way to make a side channel attack on the Crackme. There are some more fancy timing attacks as well, and you can sometimes observe just how the memory changes, and based on that you can already see what character is correct and what character is not correct. I'm not saying that it will happen with every Crackme, it all depends on the actual algorithm which is used, but that might happen, and you might be able to use that method, and it will actually do you quite a lot of good, as in it will save you quite a lot of time if you get it right. If you don't get it right, or if the method turns out not to be working because you don't know until you try, usually that means You made it. Huh, this is funny. That means, yeah, I mean, you wasted time. Okay, so what I'll do now, I'm going to just run Binary Ninja on it again and see if the trick which KrzaQ described. I'm sorry if I pronounced your nickname incorrectly. So you said to basically, I'm going just to mark. Can I mark like no? Okay, in hex view, is this the hex view? I think it's the hex view. Is it not the hex view? Oh no, this is the hex view. Mark whatever, transform, XOR, and encryption key X. No, just put it here, apply. Whoa, I so need to learn Binary Ninja. That's awesome. That would save so much time. Though, that's not true. As in, I would probably write a script anyway, because I like this approach where I'm doing transformation on an executable file, which are repetitive, which means I can repeat them at any time I want to, just changing minor parameters. Because, you know, if you just change anything in an exe file, and then you find out yourself that no, this is not the correct solution, I need to backtrack, that means it becomes painful, unless Binary Ninja actually stores the changes, which is possible, and that would be really awesome. Let me know if you know. So the last character might be a null terminator. That's one of the suggestions from Dex isn't. I guess you mean here, but this is the terminator, the weird R. Yeah, I actually think so as well. It's either that or it's part of the encryption, obfuscation scheme, because it's used all around. Cool. So, what do we do now? Oh, there's actually some... So we get to actually you made it, right? And this probably gets somehow displayed. But there seem to be, if you look at this graph here, I'm sorry, at this chart here, there's quite a lot of code left. And I'm not naive enough to think that isn't important. Yeah, so okay, I could do this forever. Now what I actually, since my stream is again 1 hour, let's try to run it under a debugger, the obfuscated version. And file format is not recognized, seriously. Come on, GDB, well, you're failing me. Which means I cannot run it in GDB, because the author of this challenge made some changes to the executable, which prevent it from correctly loading in GDB. Which is okay, I guess, because that doesn't mean I cannot debug it, right? What it means, I need to first run it, and now I need to, in another console, I need to attach the debugger. This isn't too convenient sometimes okay, but I cannot probably do it because it's already running ptrace-me, right? So I can try if I can attach it. ps aux grep. Sorry, what's the name? oxf. Yeah, I can try to attach. Sudo gdb pid, and this is the pid. No process, attaching to process, ptrace, no such process. That means that, you know, ptrace-me is in effect, so yeah, it seems I cannot actually run a debugger on it until I deal with the whatever, well, the ptrace obfuscation, basically. So I'm going to kill it, kill all -9, yeah. No process, oh, let's kill, yeah. So what to do in such a, what do you mean no such process? I'm pretty sure there's such a process. Oh no, that's grep, so sorry, I think I made a typo in grep, so that's why it's not working. Because it's the obfuscated. Yeah. I'm sorry, let's try it again. Sudo gdb and the correct one. Yeah, operation not permitted, this starts to make sense finally. Now I can kill it. Kill -9, yeah. Okay. Wrong pit, that's true. You wouldn't believe how many times this happened to me. I usually just, yeah, I usually, what I do is I do another pipe and grep and dash v grep just to be sure I don't get this IP. I think there's also like another nicer command to do it, which I never remember, like pid off or something. Cool, so what would I do now normally? Now, you remember I did find here regular expression. No, I'm just looking for int. Interactive, perfect. No, not until here. Yeah. Now, this instruction. This instruction is the only int I have encountered so far. Therefore, what I could do and what I'm going to do is what offset is it on? It's on this offset. I'm going to change it to int3. Int3, which is obviously the breakpoint, which means that if there is no debugger, it will just crash, but it will also dump the core. And I want to see what, basically what syscall is like going in there. I could maybe find the EAX, but I don't, yeah, just to show you another method. I probably find it statically as well. But yeah, just to show you another method, d equals cc. cc is probably the one of a few opcodes you need to remember, and that stands for int3, which means debugger breakpoint, or software breakpoint actually, because there are different variants of debugger breakpoints, obviously. Now, I need to rerun it again, Python go, and I need to actually copy this to my TMP, because I'm on my Windows partition and a core file will not save here. That's one of the downsides of my configuration, basically. So I do cd tmp, and now I run it. No, you limit -c unlimited, which means I allow the system to dump the core, and now I can run it. Obfuscated. Yeah, and it stopped. It didn't. Why did it stop? That's quite weird. That's a weird behavior. It should have. Oh no, because it's tracing itself. That's why it stopped. That's unfortunate, but that also tells us something really, really important. Kill all obfuscated. Yeah. What it tells us, it tells us that the actual ptrace happens before, right? You can do strace on it. Yeah, it happens before. It happened because if it wouldn't, we did patch this out, right? We did patch the int out, unless no, the address is correct. So it means that I should look before that to actually be able to find where the ptrace was run. Yeah, so Vesim says that, oh, int 80 has 2 bytes. That doesn't matter. That doesn't matter because, well, you know, the CPU takes the first byte and checks what opcode is it and whether it should load more bytes. Now, since it finds this instruction and this instruction is only 1 byte, then it will just execute it. So that's okay that I overwritten only the first byte of this instruction. That's pretty normal, actually. Okay, so let's do it like this. I'm going to do the stream like, let's say 5 more minutes, try to find this ptrace and disable it. If, yeah, and then I'll finish, and you'll find the write-up to how to solve this challenge when I finish it, obviously, on my blog. And I'll link to it in the next video as well. So again, if you have any ideas what I could talk about next time, let me know in the comments under this video. And yeah, again, I was supposed to show you how to start with a Crackme. So this is how you start with a Crackme. If you would like to see how to start with another Crackme on a similar level, let me know. And we can take another Crackme, because after, you know, after the recon phase and so on, looking at in the hex editor, you jump down to actually playing with a Crackme. So yeah. This was the part of the code which, what was it related to? No, that was related to the, that's just before the loop. So I should probably not, yeah, I should probably not touch that. What's this? This is funny. But that's not, oh, one quick thing, how do you find int3? Because what I'm looking for is, sorry, int80. What I'm looking for is int80, the place where it actually calls the ptrace_me. Now you can do it in a couple of ways. First off is, and probably the best one is strace-i. Yeah, and strace-i shows you where is it, right? And it's here. So yeah. So I'm just going to use this method. The second method, which I wanted to, which doesn't involve roaming in the code. In the hex editor view, you type Alt-T and look for CD. Just CD probably. CD is the first opcode of first byte of opcode for int. It's CD80 would be int80. That's probably the second opcode which you should remember if you're yeah, actually you don't have to, you know, memorize all the x86 opcodes, but there are a couple of them which you should. And that was the CC, and that was the CD, and that was also C3, which is return. And 90, which is NOP, which is, well, you know, just no operation. Or as people know, it's just exchange EX with EX, but that's not really important here. So I'm going to jump to this address and see what's here. Oh, actually, this is a part which I did not explore yet. I'm going to jump here again, but yeah. And it's, yeah, CDO. Why is it CDO? That's quite weird. So this is probably, this means that, oh, and I'm quite like at the end of this, right? So what this means is that this is probably patched somewhere with 80, or maybe this whole code is deobfuscated or decrypted again. There would be 2 layers of encryption, because why not? So, so yeah. Which means I can, I still can do the same trick, but change A4D, change this offset to A4D. And yeah, and let's run my, okay. So I'm going to type popd. Now, you might have noticed that when I do cd on my console, actually a whole list of directories appear, right? Now, this is because cd, in my case, is actually an alias for a command called pushd. And pushd, something changes the directory to pushd, but saves the old directory, the current working directory you were in. Therefore, when I do popd, I return to the previous one. And previously, I was in, well, the directory of the challenge. So this saves me typing when I just want to go back up the directory stack, basically, right? Yeah, so I do, again, python go py. And now I do, and I, again, copy the obfuscated. I probably should do some script to it, but whatever. And then I do cd again, and I run the obfuscated again. And yeah, perfect. Core dumped, trap breakpoint. That's exactly what I was looking for, which means I can do now gdb core and core file. Yeah. And it terminated at this address. I have absolutely no idea why it terminated at this address, but that's pretty weird. Where, okay. Registers. What registers do we have? Okay, that's pretty weird. It might be some quite interesting or quite crazy obfuscation, again, technique. So yeah, for example, what could have happened is that the author of the task, before patching this, would actually calculate a checksum of all the instructions here. And for some reason, it was detected, or for some reason, because I patched it, right? It was detected that the checksum is not correct anymore because somebody patched it, and therefore it basically destroyed the stack and went to this address. Was the stack really destroyed? Probably no. ESP is still valid, so what I can do is I can do xxd, probably no, x10 word x from ESP. Yeah, these are probably correct addresses still, so I can just go here and see where am I at. This looks like part of it, actually. Before that it was this address. Oh, and this is a part I don't have explored for some reason. Let's explore it. Anything interesting here? Absolutely nothing. So yeah, this didn't give me too much. Therefore, it means that the next step I'm going to take, obviously offline, is I'm going to read the code more. I'm going to try probably, maybe I'm going to write a script which deobfuscate this, right? The pattern which is used like all around this binary. I'm just going to change every pattern like this to no ops, to no operations, enough of them to fill the whole patterns. And then I'm going to look through the code, look if there is actually a checksum, and yeah. And then I'm going to write a write-up and I'm going to post it on my blog. So if there are any questions that you would like me to answer now, just let KrzaQ know and he's going to tell me. I already see there are a couple of questions there, so yeah. So I'm going to answer them. Again, if you have any ideas what could be the next topic for the stream, then let me know. Otherwise, Philip says, I'd love to see micro-corruption CTF challenge. So what I need to check is whether micro-corruption actually allows me to solve challenges online, because, you know, in case of some war games, for example, they say that please do not publish, you know, write-ups or anything, don't show how to solve the challenges, even though there is no competition, but yeah, just please don't do it because people want to have fun. In case micro-corruption doesn't do it, I can do some challenges from there as well. I did hear really, really good things about micro-corruption. Now, yeah, let me switch here. Liam asks, so will on my channel, will I be doing only reverse engineering and opponing content, or will I be doing also web challenges? I will be doing web challenges as well. I will be doing crypto as well, some networking probably as well. Yeah, it's basically up to you guys, or you folks actually. If you have any idea what you would like to hear about, is it web or crypto or whatnot, if you have an idea, just put it in the comments under this video. And I will try to make it happen if, of course, I'm able to, because, you know, you might ask for a topic which I have no idea about and I just won't be able to do it. Isn't that address the name of a challenge maker? Yes, it is. And yeah, that's usual. Why not? Especially if you have like a handle which fits into hexadecimal values and you can fit them inside the register then. It's basically his way of saying he caught me red-handed on trying to tamper with his challenge. What tips do I have for a beginner in reverse engineering? Actually, if you could watch my previous video that was mostly about tips for a beginner reverse engineer. So yeah, take a look at it. But yeah, practice in the end. That's all it is. Do I recommend any security training about exploitation, IoT hacking? Not really. I'm not familiar with trainings in all honesty, so I cannot recommend anything, sorry. Anything about browser fuzzing? We could chat about browser fuzzing at some point, why not? That's quite an interesting topic. I would have to prepare for the stream, or maybe invite a guest, actually. Yeah, that's possible. I'll keep it in mind. Are there any other questions, or should we finish? Yeah, this video, as all videos, will be on YouTube. It will be archived basically immediately after the stream is over. Okay, any good resources to learn reverse engineering and pwning? There are a couple of books which you might find interesting. I think I talked about them already, but whatever, like last stream. Bruce Dank has written one, Practical Reverse Engineering. Is this? Yeah, this one. Yeah, this one, Practical Reverse Engineering. You might find it interesting. Bruce was actually working in Microsoft security for some time. Now he moved to another company. He's actually like a great guy, and yeah, and his book is also awesome. Apart from that, there are like a couple of other books. Like for example, there was Reversing, but it's pretty old now, I believe. Reversing Secrets of Reverse Engineering. This one, yeah. This is the book which I actually learned from back in 2005, so it might be quite dated. but it seems it shows us quite a lot of other books. Practical Malware Analysis is quite a new book from No Starch Press that might be quite interesting as well. Rootkit Arsenal is a cool book. I have it on my, actually, there, like, I took it out to read. But it's not really about reverse engineering. And then there is one book which I really liked. It might be a little dated as well. It was called Hackers Disassembly Uncovered by Chris Kaspersky. You might know him by his handle, which is Nezumi. Yeah, this one. Now, the author, Chris Kaspersky, actually released the first edition of the book. You can find it in a PDF that was like an official release from the author of the book. What I liked about this book was that he basically went through all the basic C++ structures and whatnot, like code patterns, and explained how they look like in C++, how they look like in assembly, how to reverse it. That was it's a little dated now probably, but it was pretty cool. Probably there are other stuff as well in terms of books. In terms of other resources, I already mentioned Tuts for You today. This site has like such a huge archive of papers, tutorials, and everything. That's quite amazing. So yeah. Apart from that, you know, if you're looking for older stuff, openrc.org has there's some cool stuff here as well. Though the last time the site was updated was 2008. Yeah, so you're probably not going to find anything about Intel 64-bit or actually AMD 64 on that site. Which tool framework do I use for dynamic analysis using Python scripts? GDB. I actually do GDB scripting in Python. Yeah, it's personal preference. I probably should learn some DynamoRio or whatnot, but yeah, at this moment usually it's enough for me to use Python with GDB. Are integrals useful in reverse engineering? I have an exam in few days and I want to believe they are useful from Igor. Yes, they are very useful. If you would be doing 3D graphics, then probably yes, but no. Cool. Yeah, Pintool is one of the choices. Do I like Radari too? I think I'm like being asked this on every stream. With Radari 2 for me is like this. When I have the time to learn it, to learn the user interface of it, then I might like it. Currently, I just don't know. I'm a little terrified by the interface, in all honesty. Can I elaborate how to set up my environment? Actually, I can give you a link to a document where I have everything written down. If you go to my GitHub, which is like, you know, github/gunveil, then there is this iFace. iFace stands for interface, obviously. And it's a rather bad Windows, Linux, RPC interface, but so this is a set of scripts that is not the important part. The important part is the link here, which leads you to a document, my notes, my set of notes on how do I set up this, this environment basically. And it's not complete, but it's basically, I try to update every time I set up this environment. I'm doing it, let's say, every half a year on some other computer or laptop or whatever. So these are pretty much up to date. If you speak Polish, there's actually a 3-hour video on it, how to set it up. If you don't speak Polish, well, it's still a video, right? So you can see what I'm doing. And again, I might get to actually doing an English video on how to set it up as well at some point. And the video link is inside that document, which I pointed to. Cool. Okay, so it's 9:15. Thank you very much for staying so late with me. Again, the solution for the Crackme will pop up on my blog a couple of days from now. I'm probably going to work on it on the weekend. Thank you to KrzaQ for being the moderator today. Thank you for everyone for coming. If you liked it, yeah, thumbs up. I always enjoy them, and subscribe to my channel, and see you next week. Again, this show is happening every Wednesday on 8 p.m. Central European time. So thank you, and I'm leaving you with, well, the usual music. See you.